Hello, and welcome to this lesson of probability. We're going to be looking at the probability of events not occurring. So let's jump right in. So probability, like we said last lesson, is probability or chance, those words are interchangeable, of how likely something is to happen. And we can represent probability on a probability scale. On the left-hand side, we talk about impossible things, or we say they have a 0% chance of happening. And to represent this as a number, we would use the number 0. And on the other end of the scale, things that are certain, they have a 100% chance of happening. We represent these with the number 1. And we talked about examples of things like this. So we talked about impossible, unlikely, equal chance, likely, and certain. And we talked about some examples of those things with those probability or chance of happening. So this lesson, we're going to be calculating probabilities of things not happening. So if we roll a fair dice, what is P3? Remember, P brackets 3 just means probability of that happening. It's just probability of, and it could be anything. So in this case, what is the probability of rolling a 3? So what is the probability of rolling a 3? Well, let's think about the numbers on a dice. We've got 1, 2, 3, 4, 5, and 6. So if we think about the formula again for probability, we talked about successful outcomes. Successful outcomes divided by total outcomes. Okay, and that is how you work out your probability. Okay, so in this example, what is the probability of rolling a 3? Well, we've drawn out all the possible outcomes, of which there are 6, because there's six total outcomes. There's 6-sided dice, there's only 6 outcomes. So that means our answer is going to be something over 6. Now, how many of these outcomes are a 3? Sorry about that. Well, there's only 1. There's only 1. So therefore, the number of successful outcomes is 1, and there are 6 total outcomes. So probability of rolling a 3 is 1 over 6. And you don't need to convert this into a decimal just yet. Just going to leave it as that. So probability of rolling a 3 is 1 over 6. Job done. Okay? Now, what is the probability of not rolling a 3? So again, if we consider all the numbers on a dice, we've got 1, 2, 3, 4, 5, and 6. Again, the number of total outcomes is 6. We have six different numbers we could roll on the dice. Now, how many of these are not a 3? We got 1, 2, 3, 4, 5 different outcomes, because all of these numbers aren't 3. So the number of successful outcomes of not rolling a 3 are 5. So therefore, the probability of not getting a 3 is 5 over 6. Okay, job done. So just when we talk about the probability of something not happening, we need to think about all the instances where it doesn't happen. Simple as, and you just count them up and you add them all up, and that will give you the probability of something not happening. Okay, let's have a look at another example. So the spinner below is spun and the letter is recorded. Event B represents the spinner landing on the letter B. Therefore, P of B is equal to the probability of landing on a B. Remember, this P here just means probability of, in this case, event B. Okay? And we're told that event B is when the spinner lands on a B. So we need to find the probability of the spinner landing on the letter B. Let's think about this now. So how many different outcomes are there on the spinner? If we start from the top, we've got A, then we've got B, then we've got B, then we've got B. So these are all the different outcomes. And if we remember our formula, keep missing out the extra C, successful outcomes divided by total outcomes. Okay, And we know there's 4 in total. We know there's 4 total outcomes, so the number on the bottom will be 4. And how many of these outcomes are the letter B? Well, just count the letter B's. We've got 1, 2, 3. We've got 3 letter B's. Therefore, the successful outcomes is 3. So the probability of the spinner landing on the letter B is 3/4, 3/4. You should hopefully all know that as a decimal is 0.75. Okay. Now, this notation here, now you've never seen this before, B' or B'. Okay. So this B' is known as B prime, which is also known as not B, which is also known as event B not happening. So they all mean the same thing. Long story short, if you see B', you're not trying to find the chance of event B happening. You're trying to find the probability of B not happening. So in other words, instead of saying not B, we use B and this little apostrophe. And that tells us that we're trying to find the probability of this not happening. Okay, so let's go through it again. What are the total outcomes of this spinner? Well, we've got A, we've got B, and we've got B. So remembering our formula up here, successful outcomes divided by total outcomes. Well, there's 4 total outcomes here. So 4 goes on the bottom. Now, how many of these outcomes are not the letter B? Well, there's only one. There's only one letter A out of all these options. So that must mean there's only one successful outcome. Therefore, the probability of B prime, or the probability of B not happening or not getting a letter B, is equal to 1/4, which as a decimal is 0.25. Okay. So now we're throwing in, this is really formal statistical quotations, okay, or notation. So B prime just means not B. Let's have a look at another example. So we've got a bag of marbles here. A marble is picked random from the bag. Event A represents a yellow marble being picked from the bag. Therefore, P of A is equal to the probability of a yellow marble being picked. Okay, so we've talked about all this before. Hopefully don't need to go over this again. Just P brackets just means probability. So we've got 2 questions. We need to find the P of A, and then we need to find P of A prime. Remember, this is not A. This is P of not A. Okay, it's the same thing, just using a different notation. So first, let's do P of A. Remind ourselves the formula for probabilities. It is successful outcomes over total outcomes. So we've got P of A here. Now, so we're trying to find the probability of picking a yellow marble out of the bag. So you can do this either way, it's up to you, as long as you remember which number goes on top and which one goes on bottom. Let's stick with the bottom number first. How many total outcomes are there? In other words, how many marbles are in this bag? Well, you count them up. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We've got 10 marbles in this bag. So the total outcomes is 10. There are 10 total marbles in the bag. And we want to find the probability of A. So that's going to be how many yellow marbles are in there. So count the yellow marbles. 1, 2, 3, 4, 5, 6. There's 6 yellow marbles. Therefore, the probability of picking a yellow marble out is 6 out of 10. Now, can't just leave it as that. We need to simplify the fraction, divide them both by 2. That will give you 3/5. And there you go. That's your final answer there. If you did want to turn it into a decimal, it would be 0.6. Okay, so job done. So that's the probability of finding A. Now, we're going to find the probability of not A. Okay, so again, successful outcomes over total outcomes. Well, we're dealing with the same bag of marbles, so there's still 10 marbles in there. But how many of those marbles are not yellow? Well, we're going to count the blue ones. 1, 2, 3, 4. So there's 4 marbles that are not yellow. Therefore, probability of not A is going to be, there's 4 successful outcomes. So it's going to be 4/10. simplify the fraction to 2/5 and turn that into a decimal will give you 0.4. So well done. Hopefully you got those right, or hopefully you spotted those as I was working them out. Now, some of you might have noticed that P of A and P of A prime, if you add them together, you will always get 1. Okay, so let's think about this. So P of A plus P of A prime, I'm saying it always equals to 1. Well, let's double check that. So we can use the non-simplified fractions, we can use the decimal answers, it's up to you. Let's use the first fractions we got, 6/10. So we said the probability of getting A was 6/10, and the probability of A prime was 4/10. Add them up, 6/10 plus 4/10. The denominators are the same, so we can crack on. 6 plus 4 is 10, has to be over 10. 10 divided by 10 is equal to 1. There you go. So we've shown A and A prime have to equal to 1, okay? So that's the way you can double check your answer. Sometimes it's easier to figure out what the chance of the event happening is, and then you can use that to very quickly figure out what the chance of the event A not happening is, okay? Because they both have to add up to 1. Okay, so here comes your main task now. So all of these questions, they all are asking you to find the prime. None of them are asking you to find the probability of event A, just event A or just event B. They're all asking you about the prime versions of the events, okay? So none of them are just the event happening. They're all asking you about the events not happening. Okay, so pause the video and have a go at these 4 questions, okay? Best of luck. And here are the answers. So just double check them. If you've got any answers totally wrong, or if not totally wrong, if you take your answer away from 1 and you get the answer on the board, that means you've just figured out the chance of the event happening, not the event prime, or not the event not happening. Okay, so just be really careful with that one. And the last question for part C, find the probability of C not happening. Well, there were no green marbles in the bag, so the chance of you not picking a green marble is 100%. You can't not pick a green marble. Okay, so you can't pick a green marble out. Let's have a look at the checking question now. Okay, so here's your checking question now. A standard deck of playing cards consists of 52 cards. All cards are divided into 4 suits: spades, clubs, hearts, diamonds. In each suit, there are 13 cards. These include a 2, 3, 4, 5, 6, 7, 8, 9, 10, a jack, a queen, a king, and an ace. If a card is chosen at random, event A represents a number card being picked. So P of A equals the probability of picking a number card. I'm asking you to find P of A prime. So pause the video, see if you can have a go at answering this question. Okay, best of luck. Okay, so first things first, what does P of A prime mean? Well, this means we're trying to find the probability of not A, the probability of event A not happening, which in other words is the probability of not a number card. Not a number card. Okay, so that's what we're trying to find. We're trying to find the probability of not picking a number card. Well, let's think about our formula. To find probability, it is successful outcomes divided by total outcomes. So therefore, let's start at the top. How many total outcomes are there? In other words, how many cards are there? Well, there's 52 cards. So we could pick any of the 52 cards. 52 cards in total. How many successful outcomes are there? Remember, we're trying to find the probability of not A. Okay, so how many cards are not number cards? Well, we've got jack, queen, king, and an ace. We've got 1, 2, 3, 4 cards that are not number cards. But remember, we have four 4 non-number. But remember, there's also 4 suits. So for every card, there's one of each card in every suit. So we've got the 4 number cards, and we need to multiply that by the 4 different suits. So 4 times 4 means that there are 16 non-number cards in a deck of cards, okay? So therefore, that's our number of successful outcomes, non-number cards. So we got 16. So we've got 16 over 52. We need to simplify this fraction now. 4 goes into both of these numbers. There are 4 4s in 16, and there are 13 4s in 52. I'm not going to ask you to simplify that. That's fine. So hopefully you got 4 over 13 as the probability of not getting A. Okay. Now, some of you might have worked out the slightly longer way of working this out. Well, actually, it's not longer. It's just slightly different. Some of you might have worked out that the probability of A prime is equal to 1 take away probability of A, because P of A has to add up. A and A prime have to add up to 1. So some of you might have figured out that you would need 1 take away 36 over 52, which is the same as 52 over 52 take away 36 over 52. And that would give you the same answer as 16 over 52. Okay, so there's 2 different ways of working it out. You either do one of probability A happening, so 1 take away P of A happening, or you can just go straight in and actually figure out the chance of A not happening. But either way, you get the same answer. 16 over 52 simplified to 4 over 13. Okay, so very well done, guys. Good lesson, and we'll see you next lesson. Bye now.